So I said this, no, for any symmetrical body E would be 0. Now for, I'll say, for different shapes. So suppose there's a line, just a line, for that it would be E is equals to k cube by r square. Now here if there's a ring, ring bole to I'll show. If there's a ring like this and you have to calculate somewhere at point here, इधर इसके बीच में से एक पॉइंट गया, you have to calculate it here. Then how will you calculate? There's a formula for that. It would be E is equals to k cube by r square plus x square to the power 3 by 2. Now this formula you have to remember, baby. What is r? R is the radius of this ring and x is the distance from the center to this point A. Now next shape is like disc. Disc, it would be like, wait, like this coin. If there's a coin like that and you have to find it here, so how would you do? There's center, distance r, and here there's a point A. This distance is x. E is equals to k cube. What was the formula? I'll check, wait. रुकना. ओह नो, के क्यों नहीं आता क्या? सॉरी. E is equals to sigma 2 epsilon naught 1 minus cos theta. According to them, I don't know cos theta. Cos theta, what is theta? This angle. Cos theta. If you don't know the angle theta, then what do you have to do? Then E is equals to sigma 2 epsilon naught 1 minus x by under root r square plus x square, I guess. Yes. R square plus x square. Now what is r? I have already told this distance r. डिस्क एंड रिंग में फ़र्क क्या है? रिंग के अंदर जो है इट इज़ hollow space and disk is like filled, like coin is filled, right? So I have drawn it like this. R is this and x is this. You have to find this formula. Now you will be wondering what is this sigma. One more term will come, lambda. Lambda is like linear charge density. Linear charge density. Lambda is equals to q by L. Linear q is charge and L is the length. Now what if it's like non-uniform? So you would say dq into L. Sorry, dq means charge का small part is equals to lambda times of dl. dl बोले तो I'll say in the next, what do we say? I mean next page. Then next comes for this sigma. Sigma is surface charge density. This is equals to, again, charge by area. For here we took length, no? For this we have to take area, because this thing में surface area will be calculated because it is filled. Here it is not filled, so you have to calculate the normal thing, not the surface area. Now if it is not uniform, this is the uniform, like everywhere it is this, like here everywhere there is the same quantity of material filled. There is no up and down. But what if there is up and down? So we'll do dq is the smaller charge taken, is equals to lambda times of dA. That's it. That is charge by area. Whose area? The surface का area, like this coin, like according to this question, coin. Next comes rho. volume charge density. Yes, volume charge density, rho is equals to charge by volume. किसका volume? I'll say in the next, these first and second wala, sorry, third wala, I'll say in the next page. This thing, it is over here. Okay, then this comes out to be q by, again dq is the smaller charge, is equals to rho dv. You have to remember these, bro. Like dq is equals to lambda dl, dq is equals to sigma dA, and dq is equals to rho dv. Now for the first term, linear charge density, suppose there is an arc बोले तो this is a circle, you cut some part of it, like ring में से you cut a part, and this part का angle is some theta. Sorry. Then what would be the, this is point A, electric field at A. इलेक्ट्रिक फील्ड इस पॉइंट से भी आता, इस पॉइंट से भी आता, इस पॉइंट से भी आता, इस पॉइंट से भी आता. फ्रॉम एवरी पॉइंट इन दिस एरिया, लाइक this thing, electric field will generated. So how do you find? Now I have already written this again over here. Wait a sure. E is equals to 2k lambda and r by sin theta. What is lambda? Lambda is length, linear charge density. Lambda is equals to q by l, right? Now dq is equals to lambda dl. This thing you have to substitute over here, that lambda ka value dq by dl, no? For this thing you have to substitute it here. It would come like 2k dq by dl into r sin theta. Now we know that ring is uniform, like everywhere it's the same thickness, material and all, so we can substitute this value instead of this. When do we substitute this? When this is non-uniform, somewhere it is big, somewhere it is small, but if it is the same everywhere, then you can use this. This would be 2k q by l into r sin theta. Instead of this ql, you can directly write lambda ka value they'll give in the question. If they don't give, they're gay. Actually, like they should give, at least they should. This is arc. The next thing would be sphere, I guess. Wait, let me see. Oh, next thing है rod. This is infinitely long route. Here also. No, not in the. There's a point over here. Draw a perpendicular, like draw a line, not perpendicular line. Draw a line here, over here. This would be theta 1. This would be theta 2. It's charge. How will you find the charged electric field on this point A? Now for this you have to take two components. This line, like this point, will apply force like this, and this will do like this, and this is straight line. You have to calculate, make the force, break the force into components. One component of this would go here, and one component of this would go here. Same, one here, one here. So this is the point A. There will be two forces, one this and one this. Now for this perpendicular force, this thing is called perpendicular force, E perpendicular. The formula is sine k lambda by r. What is r? The distance. This distance is r. sine theta 1 plus, you have to remember this, sine theta 2. Now for this parallel one, E parallel, I guess you can understand this perpendicular and parallel thing. It is again k lambda by r, but here cos theta 1 minus, you have to do cos theta 2. That's it. This is the formula for this thing. Now what if, I'll ask you a question, what if there's a rod like this, only one side it is extended, there's no rod below the point A, so how do you find? Then there will be only one line. Suppose this is theta charged, इसके लिए there is only one theta, right? So E perpendicular would be k lambda by r into, perpendicular के लिए मैंने बोला था sin theta आएगा, so k lambda by r sin theta, and other theta is not available, right? So we'll just ignore it. Then E parallel would be k lambda by r cos theta. That's it. What if this is down? Nothing happens. You have to write sin theta and cos theta only. But remember, correct, I am doing. Yep, correct. Yes. Just perpendicular में sin theta आता, parallel में cos theta आता. That's it. Then I'll give you some question. Like, do this. One more thing. If the rod is very long, like it goes to up very high, like Burj Khalifa tall, so the theta would come from here. This theta is nearly equal to 90 degrees. You have to bend your, you have to like look at it up high, no? So theta would be 90. So for this, there's E perpendicular k lambda by r into sin theta. Now here theta is 90, right? So k lambda by r sin 90 is 1. This thing. Now E parallel, what would happen to E parallel? K lambda by r cos theta. Theta is 90. What is cos 90? It is 0. So E parallel would be 0 over here, like this. Correct. Now what if the rod is like, here also it is infinity and here also it is infinity, and you have to find this. So both the thetas are 90 degrees. So sin theta 1 is 90, sin theta 2 is 90. So k lambda by r sin theta 1 is 90, that is sin theta 2 is also 90. E perpendicular. Now E parallel k lambda by r cos theta 1 minus cos theta 2. This thing though would go 0, because 0 minus 0 is 0, so we can cancel this out. Now E perpendicular comes out to be k lambda by r 1 plus 1, that is 2k lambda by r. For a rod that is infinitely long on both sides, if it is only on one side, either up or down, you would be answering this thing. And if it is like both the sides up to a finite distance, then sin theta 1 plus sin theta 2 for E perpendicular, and cos theta 1 minus cos theta 2 for E parallel. Now the next topic, I have some questions now. Wait. So tell me this: if there's a semicircular ring, what would be the E perpendicular? You have to find this and tell me later. I'll ask you this charge over here. Now there's a rod again. Angle here is 53 and angle here is 37 from point A. Here this point A. You have to find E perpendicular and E parallel. Next question. There's an infinite long rods on the both side, and you have to find field at A, at this point A. What would be the answer? Tell me this later. And more questions dena. That's it for NEET, I guess. Then we'll start electric flux. Yes, I'll do in the next video.